Hello, my name is Stefan, and today we'll be working on a subtraction problem and a multiplication problem. Okay, let's start. So we're going to start with doing a subtraction problem, and the problem we're going to be doing is 135 minus 79. Okay, so we can do it the traditional way, where we do 135 subtract 79. We start with our ones place, and we'll need to see, can 5 subtract 9? Well, we can't do that, so we're going to borrow 10 from 3. And we'll borrow 10, and we'll get a 15. We'll do 15 minus 9 is 6. And we're finally left with 2 minus 7. We can't do that, so we have to borrow 10 in the 100 place. We got 12 minus 7 is 5. So that's one way to do it. We got 56, which is perfect. Now, we want to promote mental math and doing it without any calculations. But for the purposes of learning this method, we can do something called landmark compensation. Landmark compensation. And this is a really cool trick. So one way to do it is to draw a number line. What we can notice is 135. It is a complement of 100. 100 is a very nice number. And we're going to take our two numbers and see how far it is from those two numbers, 135 and 79. And this makes our problem much easier. And it's going to make us go from a subtraction problem to an addition problem. So how far is 79 to 100? Well, we know that's 21. Perfect. What about 100 to 135? 35. And all we have to do is figure out what's 21 plus 35. Well, that's 56. And there we go. That's how we can use landmark compensation. If we can recognize what the bigger number is a complement of, we can use this like number line method as a trick and tool to break it down into two smaller parts that we can add up and do in our head. So that's another way to solve the subtraction problem. Okay, now let's do something that I like to call number talks. So in math, there's several ways to think about a problem. So how can we do 16 times 5? How can we solve 16 times 5? There's so many methods, and it even surprises me. So some people do skip counting, right? You can go 16 times. I prefer to go 16 5 times. So we can do 16. 16 plus 16 is 32. 32 plus 16 is 48. 48 plus 16 is 64. And then add another 16, we'll get 80. All right, now will give us 16 times 5. That is one way to do it. Perfect. So skip counting. Okay, what other methods are there? Similar to the previous problem, we can kind of do like this breaking up method. We can break 16, we can break 5. A lot of times people like to call this composing and decomposing a number. So we can compose and decompose a number. So 5 is a good number. It's easy to do 5, 10, 15, 20, and so on. So why don't we decompose the 16? Okay, what can we rewrite 16 as? Well, 16, we want a nice number. 10 is a nice number. And then 6 is also a nice number. But keep in mind that we're multiplying by 5. So we still need to keep 5 consistent for both of them. So we decomposed it into two parts. And then we're going to recompose it by putting it together. So we know 10 times 5, well, that's 50. And then what's 6 times 5? That's 30. And that's another way we can get 8. But that's another method. So we did some algebra. We can do some finger counting or skip counting in our head. But some of us are visual people. And we're doing multiplication. We can use something called the area model. So let's try that. Area model. right? We can draw out something, and this will not be drawn to scale, but that's okay. So we're gonna have, right, we can think of rows and columns. So 1, 2, 3, 4. Okay, so we got 5 rows there. So this will give us 5 rows, and then we're gonna do 16. Okay, I'm trying my best. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I need one more, so I'm gonna go right here, 15. Okay, so that will be our 16. There'll be 16 of them. And then, so we know this whole thing is 16. So some of us, we may want to count it, and that'll probably take too long. But some of us are visual people. So when we did the compose and decomposing a number, it might not be super obvious to just break it up 10 and 6, and then we'll multiply by 5 and then recompose it and get 80. So we can look at it. The 5 is good, but that 16, we can decompose that into 10 and 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that will give us 10 right here, which is perfect. And we know this last part will give us 6. So essentially what we're trying to do is find the area, right? Area is base times height, or length times width. So we do 10 times 5, we'll get this blue area. And if we do 6 times 5, we'll get this red area. So the blue area will be 5 times 10. And the red area will be 6 times 5, or 5 times 6. And we would get 30 and 50. And for those who are more visual, this is another way to solve it. Okay, now we can do one more method. And I like to call this would you rather. So a lot of these are your preferences. This one I like to call it would you rather. So would you rather just do 16 times 5 and do all the previous methods? Or we can do another method. We can just pick something else. Why do 16 times 5? No one's forcing us to do 16 times 5. I'm gonna pick a nice number. I like nice numbers. 20 is a nice number. 16 is close to 20. So let's pick 20. That's a very nice number. And I multiply by 5. Ooh, that's sweet. I got 100. Okay, but the original problem is 16 times 5. Just keep in mind, well, all I did is 16 to 20 is 4. I added 4, right? So we have to reaccount for that. So no problem. Well, I'll just do 4 times 5. Keep in mind, we had to go plus 4 here, right? So 4 times 5 is 20. Now we want to take away that 4 again and multiply by 5. And when we do that, we will get 16 times 5. And we know 100 minus 20 is 80. And that's another way we can solve it. And I hope that doing this number top can show that, honestly, doing multiplication, it doesn't have to be the old-fashioned method. As you can see, we did not do 16 times 5 at all. We didn't do 6 times 5 is 30. 1 times 5 is 5 plus 3 is 80. That was like the last method I did, actually. There's many ways to do math, and that's what makes math so great. Thank you for coming and watching my session. Bye.